Hello there, welcome back to my workshop. In this video I'm going to be reusing old retro keyboards and converting them to USB, all thanks to the fabulous Raspberry Pi Pico. The way that we're doing this is using the KMK firmware that was developed to allow people to make their own custom keyboards. So it's perfectly set up for most of the keyboards that we're going to be looking at today. So I do have a few keyboards that we can actually get going. So I have Atari XE, Commodore 64, Spectrum Plus 2A, Amstrad CPC, BBC Model B. There is another option for an Amiga 600, but unfortunately I don't have that keyboard at this time. So there was a couple of parts to this video. First, we're going to be looking at my prototyping. Then I've got boards that was ordered from PCBWAY, who are the sponsor of this video. After that, we will quickly look at the way that the firmware works and how I adapted it. So if you're interested in reusing your old keyboards, this is the video for you. Let's just get on with it. So hopefully you all recognize this, and it was my very first MiSTer case using the Ajaz keyboard. And part of the problem was it didn't look much like a retro computer. It didn't have that keyboard look. It shouldn't be rectangular. It should have like jaggedy bits on the edge. Plus, you can never really get the same keyboard in the same countries and just all sorts of problems. But it was good, you know, but it wasn't what I wanted. I always wanted to have more of an actual retro keyboard look to the final case. So that's what got me thinking about using old retro keyboards instead of a new mechanical keyboard. The other option is to design a new keyboard, and it is a possibility using the same techniques that we do today with the Pico and the KMK firmware. We could redesign a keyboard so it looks more retro. But this was my starting point. I have a couple of keyboards left over from other projects. So this is the Atari XE keyboard, and this was left over from one of the shelves that Johnny sent me from Reused. So this was one that I could use. I have a couple of Commodore 64 keyboards. These are all very easy to get going. I've actually done this in the past using a Teensy, so I could make a Raspberry Pi based Commodore 64. So that one is also very easy to get going. I've developed another case for the NGO, which is the Spectrum Next clone. And for that one, I was looking at my options for actual Spectrum keyboards. So I brought this Spectrum Plus 2A keyboard. I know that I can get this one going. So this one is another relatively easy one to convert over to USB. A friend has loaned me this Amstrad CPC keyboard just because he had it spare, and it's another very easy basic matrix style keyboard. So that one should work, and it should be very similar to the Spectrum Plus 2A because they're both from Amstrad. The last keyboard that I've actually got, and I borrowed from another friend, is this BBC Model B. Now going into this, I didn't know how this keyboard worked, and it is quite different to the others. It doesn't have a basic matrix, so rows and columns, and it uses some 74LS logic. So I did think that this one would be difficult, but thankfully somebody has already done this, so I can just use their GitHub project, and it does use Circuit Python, which is the same background system as the KMK firmware. So it's just a script that we can drop in. So in the end, not so difficult after all. But what we've got to do on all of these is hook up to the connectors for each keyboard and then get them linked up to a Raspberry Pi Pico. Now they're all slightly different. The BBC is just a basic pin header. The Amstrad CPC is a flat flex ribbon, but you'll see that they're like one on top of the other. The Spectrum Plus 2A is another flat flex ribbon, but they're spaced out side by side. The Commodore 64 is just a basic pin header, so that one is no trouble. And the Atari XE is another flat flex, but it's one long one. It's 24 pins, and I just couldn't find those in the UK, and I was having trouble finding them. But thankfully, all of the flat flex cables that we do use are all spaced in the same way. So on all the boards I use the same 16-way connectors, and I just space them in different ways. So we'll take a look at that shortly. My first steps was to make prototype boards on my CNC, and the main layout was to be as simple as possible, but to have the spacing for these connectors for each type of keyboard in the correct spot. So you can see this one is laid out for the Spectrum Plus 2A, but with a little bit of tweaking we can use it for the Amstrad. This is for the Atari XE. You'll see it's the same two connectors as the Amstrad and the Sinclair, just how they're spaced together. And this one also has circuitry on there to turn the LED on. Then we have this one for the Commodore, which just has a pin header, and this one is the BBC, and that also has a pin header, and I made up my own lead. For all of the boards they have the same Raspberry Pi Pico that goes in the middle, and I've just got them on these headers so that I can chop and change them around, and they just push in, and then I can take that off and put it onto the other boards. So the basic principle for all of them is the same, and it's just wiring up the connections of the keyboard up to the Raspberry Pi Pico. For the Commodore 64 one, I made sure to leave the little pin out for the key. So that just fits on. So the prototype boards were good enough to do all the testing and figure out what I could and couldn't get working. So the next step from this is to take my prototype design and convert them over to proper PCBs that we could get made. This is an example of one of the circuits, and it's for the Plus 2 and the Amstrad. So in the middle we have the Pico, and I'm just going to overlay a Pico graphic now so that you get a better idea. Then at the bottom we have the connectors for the flat flex, and they're spaced out for the Spectrum Plus 2A keyboard. And then you can see it's just a matter of connecting up the pins on the Pico down to the flat flex. Because I'm designing this originally for my CNC, it's very simple. It's laid out with no crossing tracers, no vias, and everything fits onto a single-sided board. So this is the board that I redesigned for PCBWAY to make, and we can see that it's a lot more compact. So we still have the Pico in the middle, and all the lines are connecting up to the flat flex connectors. The connectors are still spaced out for the Plus 2 keyboard, but I was able to use dual layer boards, and I just let the auto routing wizard do all the work so that I could make it small, and then we added in some screw mounts so that we could fix it into something. Once we've got our designs, then we can just download the Gerber file and upload it to PCBWAY. So now we go to PCBWAY, and if we do an instant quote, there are a lot of options on here. So what I've found, and what I recommend if you just want to do it quickly, is use the quick order PCB. And we can just add our file, and it automatically generates the size of the file and the basic settings that we need. So we could just leave it as it is and not do anything else. So for very quick and easy, I think that is the best way to do it. And then you can place your order, and depending on your shipping, the boards will arrive within a few days. So this is the box that they sent me, and we've got some goodies in here as well. So Atari XE, Commodore 64, BBC Model B, Spectrum Plus 2A and Amstrad CPC. And like I said, there is one more board that I had made, which is for the Amiga 600. This was a project that I've already found, and I'll link to the Gerber files and also the GitHub if you wanted to make your own Amiga 600 to USB adapter. So unfortunately I can't make this one up at this time. Also in the box we have this very, very nice 3D printed PCBWAY logo. The quality of this print is exceptional. Then we have this lovely footprint. I wish I'd had this when I was doing the microscope test. We could have zoomed all the way in. I love the black and gold PCB. So this will be good for checking the size of components. And this PCBWAY ruler, again with footprint sizes, trace sizes, holes and vias, and footprints on the back. And then last we have this nice collection of post-its and stickers, mainly for like debugging your circuit boards and identifying things. So thank you PCBWAY for sponsoring this video. I highly recommend their services. It's not just circuit boards, 3D printing, CNC, the number of services that they are doing just gets bigger every single day. Links in the description to their website. So really we need to solder some of these up and give them a test. So these are the boards that we just soldered up. Nothing too fancy, just connectors, and that one has a resistor for the LED. Very simple to build. So that one just needs a Pico. The Atari one is going to be a little bit fiddly. Something to wedge that under. I did cut the connectors down and trimmed them so that they join in the middle. So this should be the same as a 24-way connector that would be on the original Atari. As you can see, I have split this because of how I was doing it on the original one. But it does go in and everything lines up just as it should do without that split that I made. So that's the Atari one. So with the BBC, I made up my own lead because I didn't get one when I borrowed it. I put the green end on, so the green end goes on that side and the green wire goes to that side. So that is the connection for our BBC. And then the last one is for the Spectrum Plus 2. And I haven't cut this connector down, but what we have to do is put the leads, the flat flex in, so that the edges are touching into the middle and ignore the outside. It's a little bit tricky to see this one, so I'm going to flip it upside down. And we can get a better idea of what's going on. So that is our Spectrum Plus 2 connector. If we do the Amstrad, we just have to basically do that. So it's not a big problem. And then we just take a Pico and put it into the board. First we need to look at the programming on the Pico. I do have all the scripts ready for all of these keyboards. We just need to tell the Pico which one we want to use. Now we have our printed circuit boards, we need to program the Pico. And we're using a combination of Circuit Python and KMK firmware. So we need to download the Circuit Python image for our Pico. So we go to circuitpython.org, downloads, we click on the Pico, and we download the UF2 file. We then want to go to the KMK firmware, so GitHub KMK FW. I'll put links in the description, and we download the KMK folder. So I've got this folder already set up. It has the Circuit Python image, we've got the KMK firmware, and some libraries that we need for the BBC version. So all we have to do is plug in a Pico. And this is a Pico that hasn't been programmed, and I'm just connecting it up. and you'll see that it's now opened up a device, much like a storage device. And all we have to do is copy over this Circuit Python image. So that is now uploading to the Pico, and the Pico basically restarts itself. And now we have a new folder which is opened up ready for us to copy our KMK firmware over. And then if we go into library, we copy any of the libraries that we need. And like I said, these are libraries that we need for the BBC master. So this Pico is now programmed with Circuit Python and KMK. I'm then going to copy these files over that I've got all of my program on. So it has the boot.py, the main.py, and I'm going to rename the Commodore 64 file, just making a copy of it, and then rename that back to code. So this Pico is now set up to work as a Commodore 64 keyboard, and that was very straightforward. So if we want to actually look at the code or make changes, I'm using a program called Moo, and we basically load the code directly off the Pico. So this is the KMK program as far as what we see. It's very basic and there's lots of parts that we don't see. But the basic idea is that we have rows and columns. And the rows and columns are linked up to the pins on the Pico. So this is our code for the Commodore 64 keyboard, and this is the Commodore 64 keyboard matrix. So we have rows and columns. So in our firmware, we also have rows and columns, and these are linked in to the pins on the Pico. So this data comes from our circuit board design. We then have a keyboard map, and this map corresponds to this matrix. So as we go across, we've got kc.n1, and that just means number 1, and then kc.n3, kc.n5, kc.n7, kc.n9. So if we look in our matrix, we can see that we've got 1, 3, 5, 7, and 9. So as we're going across here, it corresponds to going down. Then the next row, escape WRY. So these just correspond to the matrix. Very, very simple. On the Commodore 64 one, I also have a second keyboard layout. And if we press a certain key, which is specified by momentary, which is just here, that means that we could do an alternate keyboard layout. And what I've done is I'm using the shift on the right side of the keyboard to change between the cursor keys, so that when we're not in a Commodore 64 emulator, we can very easily use the cursor keys to shift up, down, left and right. So very, very simple. We basically program the rows and columns, we put in our keyboard matrix. That's all we need to change for a very basic keyboard layout. We don't need to do any programming, simple as that, at least for the Commodore 64. So now if we look at the code for the Atari XE and XL, this is slightly different. The reason that it's different is because this has two keyboards in a way. So we have the basic matrix with rows and columns, but we also have the reset option, select and start lines, which are not part of the matrix, and they're actually independent buttons. So we need to set that up in the KMK firmware, and thankfully it does have that option. So if we look in the firmware, we now have this key config, which has got 4 buttons set up as a separate matrix. We then have our rows and columns just like before, but we have to specify 2 separate keyboard scanners, a matrix scanner and an independent key scanner. And then we have our keyboard matrix just like before, but it has the extra 4 buttons on there. So this took a little while to get going, And I have to really thank the guys over on the KMK Discord. They were very helpful in getting this working because some of the examples weren't quite set up for what I wanted to do. So the last program that we're going to look at is for the BBC. And this isn't using the KMK firmware. I found this website by Alex Parsons where he's connecting a BBC micro keyboard to a Raspberry Pi Pico. So he's already done all the work for me. I'll let you read through this. Basically, it gives a good explanation on how the BBC keyboard works, but it isn't using a matrix that we've got direct access to. It's running a matrix with bit shifters. So we have a clock, and when we see a key has been pressed, it sets a bit, and we have to go through and then do the bit shifting, and his firmware is already set up and working. So all I had to do was design my circuit board, which is based around his design that we can see just here. And I'm glad to report that it works perfectly. So now that we've looked at some of the programming and the different ways that I've connected these up, we really should set this up and have a look at it working with an emulator. So if we go into the Atari 800, I'm using the keyboard that you can't see. Then if we hold down F8 and press F10, we can get into the built-in ROM diagnostics. Choose the keyboard. Now we can do the built-in keyboard test. To use the control keys, you have to press control, and then it shows that the control key is working. Same with shift. So how it works okay, but as I've said, none of these, the start, select options or reset, or the spacebar works on this keyboard, unfortunately. Now we have the Commodore 64 keyboard connected up, and if we load in a keyboard tester that I found, we can run through the test on this one. So you see that all the keys are working apart from restore, because that's not on the keyboard matrix, that was a hardwired key. So I have the Amstrad core loaded up, and we can load in a diagnostic. I found Noels diagnostic, we can use that. So if we do K, and we can want to change the layout to CPC, and now we can run through the tests. I don't have an escape key, so I can't test escape. And I haven't programmed clear because I didn't know what to do with it in the core. So that's as good as I can get it, and that's based on the keys that I'm supposed to use in the core. But basically the keys are working, just some of the codes aren't recognized in the emulator. You may have noticed that we haven't tested the Spectrum or the BBC. Well, I haven't finished doing the code for them yet, and also with the Spectrum cores, they don't take advantage of the extra keys. It's only the basic keys found on the rubber key Spectrums. So we can't do a lot of the other things that we could do with that +2A keyboard. I am going to look at using the next core because that can use a PS2 keyboard. So that's on the list. And a similar thing with the BBC, that's not my code. So first I need to understand how that works. And then I need to look at how the keys are working in the MiSTer core. but it's just programming. The actual interfaces themselves that I made, they work perfectly. I'm very happy with the progress that I've made on this project. We do have 5 working keyboards that will work with MiSTer, and if we wanted to use them with other emulators, it's just a matter of changing the KMK scripts to match whatever key setups that they have. Very easy, very flexible. So there are a couple of disadvantages when using an old keyboard from an old computer, and the main one is the MiSTer cores like to use the function keys for all of the additional functions within the MiSTer. Not just loading and saving, but many different things that use the F1 to F10 keys. And we don't have access to those with a retro keyboard. And the other one is just they don't work very well. The keys on the CPC is very clunky, and not all the keys are working on the XE, and it's finding a new membrane for that, which I just can't find the one for that type. I will be putting these up onto my GitHub so you can get the code that I've written and the Gerber files and a link to PCBWAY where you can get the ones that I've already uploaded. So links in the description, and I will continue to work on these, making them better and adding more variations as I work on other emulators, maybe on the Pi, also on the PC. But I think that's it for now. Thank you for watching. Thank you for PCBWAY for the PCBs and the little selection of gifts that they sent me, and I'll see you on the next video very soon.